Geochemists, on the other hand, do not favor a cold prebiotic world. Their estimates are in the upper range, near the temperature of boiling water or even higher, compensated by a sufficiently high atmospheric pressure to keep the ocean from boiling. High temperature and high pressure are typical characteristics of underwater hydrothermal vents of the kind that have been discovered in several deep-lying areas of present-day oceans, and that were no doubt more abundant on our young volcanically convulsed planet. Also favoring a hot cradle for life is the finding that the most ancient organisms, according to comparative sequencing, are bacteria living in such vents or in volcanic springs at temperature up to 110 degrees. How about sunlight? The sun was cooler 4 billion years ago. It sent out 25% less light energy to the Earth than today. However, this was probably offset by the greenhouse effect of the atmospheric carbon dioxide, which may have been as much as 100 times more abundant in prebiotic times than today. Ultraviolet radiation most likely was strong despite a cooler sun because, there being no oxygen, there was no ozone field. One more point deserves to be mentioned about the prebiotic environment. It was devoid of life. This sounds like tautology, but it holds an important implication already noted by Charles Darwin more than a century ago. In an oft-quoted letter to a friend, Darwin wrote, "It is often said that all the conditions for the production of living organisms are now present, which could have ever have been present. But if we could conceive in some warm little pond, with all sorts of ammonia and phosphoric salts, light, heat, electricity present, that a protein compound was chemically formed ready to undergo still more complex changes, at the present day such matter would be instantly devoured and absorbed." Which would not have been the case before living creatures were formed. As a rule, this passage is cited for its reference to a warm little pond, but Darwin makes a very pertinent statement. There was nothing in the prebiotic world that might biodegrade organic molecules. This could survive and accumulate for a very long time, subject only to much slower physical and chemical degradation. Summing up, we may state first that there was plenty of water on Earth when life originated. It could hardly have been otherwise, since water is the vital element par excellence. Wake up in the desert after a night sprinkle, and you witness the miracle of water. Everywhere, seeds left to dry in a barren soil spring to life in an enchantment of colors. This does not mean that the prebiotic waters would have been our preferred spot for a South Sea vacation. They were probably scaldingly hot, perhaps bitingly acidic, and loaded with ferrous iron, phosphate, and other minerals torn from the inner depths of Earth. The atmosphere over the waters was heavy with carbon dioxide, nitrogen, hydrogen, sulfide, and water vapor, but most likely poor in hydrogen. A pale but unshielded sun filtered through to bathe the surface waters in ultraviolet radiation, light, and warming infrared rays trapped by the carbon dioxide cover. On such a planet, two possible settings existed for life to unfold. Shallow surface waters, where the soup could thicken and cook under sunlight, or dark, deep-seated hydrothermal vents harboring strange chemistries. Or perhaps currents between the two settings allowed some steps of biogenesis to occur in one environment and others in the other.